students, here we have start about the coordination compounds. Chapter number 9. In last lecture we have studied about the points isomerism of coordination compounds, that is stereoisomerism again classified into two types, geometrical isomerism and optical isomerism. In last lecture we have studied about the isomers of stereoisomers, geometrical isomer, that is cis and trans isomers in tetrahedral complexes and in octahedral complexes. Then here we are going to start about the optical isomers. Second point of isomerism, that is stereoisomerism. Here again I repeat, isomerism in coordination compound classified into two types. First is stereoisomerism, and stereoisomerism. Second is structural isomerism. In last lecture we have learned about the stereoisomerism, shows two types. First is geometrical isomerism and second is optical isomerism. Geometrical isomerism again classified into two types, cis and trans. Cis and trans isomerism in tetrahedral complexes, means complexes having 4 ligands with central metal, called as tetrahedral coordination compounds, and also cis and trans isomers in octahedral complexes. Octahedral complexes means the coordination compound shows 6 ligands with the central metal. Then after this geometrical isomerism, we are going to start here optical isomerism. Optical isomerism means the isomerism having non-superimposable mirror images or enantiomers. These isomers are also called as enantiomers. Enantiomers means mirror images. The asymmetrical compound shows this type of isomerism, optical isomerism. For example, chiral carbon, the group or the compound containing different types of ligands, central metal is bonded with different types of ligands, that is the coordination compound is asymmetrical, and asymmetrical compound shows optical isomerism. Here optical isomerism means the complexes are non-superimposable mirror images of each other, that is one compound shows their mirror image. For example, this is hand. In place of mirror we get the same hand like this. These two are the mirror images, that is this hand is asymmetrical, not in all sides same. Because of this, the nature of this hand is asymmetrical, and every asymmetrical compound shows its mirror image. That is, mirror image means non-superimposable mirror image, that is two enantiomers. For example, here carbon, OH, HCl and Br. This compound is non-superimposable mirror images, that is asymmetrical. The compound having 4 different groups called as chiral carbon. And chiral carbon denoted by the star. The sign of chiral carbon is star, and star containing group shows optical isomerism. Means this compound shows mirror image. This is mirror. Carbon here face to face, here OH, again here Br, here H and here Cr. Means these two are the non-superimposable mirror images, that is enantiomers of each other, dextro and leo. Dextro means clockwise if the priority like this way, clockwise here the priority like anti-clockwise, means dextro and leo. These two are mirror images, and this structure, these two isomers are optical isomers. But when methane shows formula CH4, all angles here symmetrical par, we get symmetrical par, means here does not shows central carbon is chiral, means the same structure seen in front of mirror, that is carbon, hydrogen, hydrogen, means there is no different one, both are same, does not shows mirror images, means non-superimposable mirror images. These are not enantiomers, means the methane compound does not shows the optical isomerism, means here the all asymmetrical compound shows optical isomerism. Optical isomerism means the enantiomers, these are the enantiomers. Enantiomers are rotate the plane of plane polarized light to the right side called as dextro and to the left side called as leo, means the plane of this compound is rotate to the clockwise, that is dextro, and the plane of this compound rotate anti-clockwise, means leo. Then optical isomers in the octahedral complexes. Here the first point of optical isomerism in octahedral complexes. Octahedral complexes means octahedral coordination compounds. Optical isomerism in octahedral complexes. Octahedral complexes means the central metal bonded with the 6 ligands, means octahedral complexes. Octahedral complexes shows coordination number is 6, means octet. Octet is 8 sides and 6 corners, that is octahedral. For example, one example of this octahedral complexes, central metal is cobalt and En3 ethylene diamine, and bracket charge, net charge is +3. En means ethylene diamine 3 times. One ethylene diamine shows 2 donating group, means one ligand shows 2 bond. For example, CO En, this is 1 En. Again here 1 En and 1 En, means one ethylene diamine donates 2 times electron to the central metal, means 2 bond, that is 3 groups shows 6 bonds. Means here the coordination number is 6, that's why this compound is octahedral complex. And octahedral complex shows optical isomerism due to their asymmetric nature. Here cobalt, then octahedral means 6 bonds, draw like this 1, 2, 3, 4, 5, 6 above, below and 4 side. Here 1 En, ethylene diamine, donates the electron. Again second En and third En. This structure of this compound is asymmetrical, when the axis of this compound, place the axis, does not get symmetry, that is this compound is asymmetric, means chiral center, therefore this compound shows optical isomers, means mirror image. The mirror image of this compound is like this way. In square bracket, central metal is cobalt, here above below, four side, four lines, ethylene diamide, या साइडला again here and this is exactly mirror image of this, that is this rotation of plane polarized light to the clockwise means dextro, small d. Here the rotation of this plane is anti-clockwise, means Leo. This is the example of octahedral complexes, means 6 bonds. Optical isomers in octahedral complexes. Then octahedral complexes existing as a both geometrical and optical isomers. This compound again in some examples we have seen about the compound shows two types of isomer, that is optical isomer as well as geometrical isomers. Some example related to these two isomers, means one example shows two type of isomers, optical and geometrical. For example, platinum is the central metal, Cl2 En twice and charge is 2 plus. This compound is asymmetrical and also shows optical and geometrical isomers. First of all, here we draw the structure about optical isomerism. Central metal is platinum bonded with En. En means bidentate ligand, and bidentate ligand shows double coordination number, means 2 group, that is 2 into 2 means 4. 6 means this compound is octahedral. 4, 5, 6. Here Cl and remaining bidentate means one group donates the 2 electron lone pair. This is the compound, the structure of this compound. The optical isomers means mirror image of this compound exactly to the like this way. Platinum, here Cl in front of mirror, Cl, again here Cl, here En and En. This is dextro and Leo. These are two enantiomers, means mirror images. That's why it shows optical isomerism. Also cis and trans. Here this compound also shows geometrical isomer, means cis and trans. For example, platinum, here Cl, En and En, Cl, En at opposite. Therefore, this compound is trans. And this compound cis, Cl, same side, En, same side. Means this is cis compound. Means PtCl2 En twice 2 plus. This compound shows two types of isomerism, that is optical isomerism, also geometrical isomerism. Then square planar complexes do not show the enantiomers, and those compounds shows enantiomers, that is these compounds having optical isomerism. Here only octahedral complexes shows optical isomerism. and square planar or tetrahedral complexes do not show the optical isomerism, means enantiomers. Therefore, the next point of isomerism is structural isomerism. Up to this point, we have learned about two types of isomerism. First is stereoisomerism and second is optical isomerism. Then second point of isomerism is stereo first. Stereo contains two. First is geometrical, second is optical. And second is structural isomerism. Structural isomerism means constitutional isomerism. Structural isomerism means constitutional isomerism. Structural isomers means linkage isomer. First is structural, again classified into subtypes. Therefore, first type of structural isomerism means chemical formula is same but structural arrangement is different. Therefore, called as structural isomerism. Structural isomerism classified into four types: linkage isomerism, ionization isomerism, coordination isomerism, and sorbent isomerism. From which first isomerism is linkage isomerism. Linkage isomerism. Linkage isomerism means the isomers are formed when the ligands has two different donor atoms. The isomer is obtained by or when the ligands attach to the central metal. These ligands having two donor group, and these two donor group donates the electron in two ways. That is linkage isomerism. For example, here cobalt NH3 5 times, NO2 2 times and 2 plus. And second one is here NO2 shows NOO, means in NO2 there is linking of by nitrogen and by oxygen, means here in NO2 there are two donor atoms, nitrogen and oxygen. In first structure, linking of the central metal by nitrogen, and in second structure CO NH3 5, here O NO and charge is 2 plus. These two are the linkage isomer. Here linking by nitrogen to the central metal and here linking by oxygen to the central metal cobalt, means NO2 shows O and N. These two are the donor groups, and in two structure linking by different donor groups. Nitrogen donates electron in first structure and here oxygen donates electron in second structure. These two are the linkage isomerism. That is, in first CO N bond means cobalt N bond, and here CO O bond means oxygen bond. This is called as linkage isomer.